and but when we fill this beaker with a liquid of up to height 2h, this person can see bottom of the rod as well. Okay, so this is case 1. They want refractive index of the liquid. Right now this person can see only top portion of rod. Can you tell me answer of this question? Yes. Suppose liquid is filled till this height 2h. Till this height liquid is filled. Okay. Agree बच्चों? Till height 2h we filled a liquid. H height is still empty. Then can see bottom of the rod. Why? Why this person can see bottom of the rod? See this. Suppose this is normal, and now suppose a light is started from bottom of this rod. Suppose a light is started from bottom of this rod and reached this point. Okay. After reaching at this point, light must go away from the normal, and this light will trace this old path. So initially when beaker is empty, person can see this rod, top portion of the rod, and when you are filling liquid, the light ray is going like this and going away from the normal like this, luckily following same path. So let's increase length of the normal. इसमें मुझे एक बात समझ नहीं आ रही. हाँ ठीक है, इसको आप बड़ा कर दें थोड़ा. ठीक है, let's draw case 1 again. Let's draw case 1 again to understand values of angle. So this is case 1. Height of the rod is h. Height of the rod is h. This person can see top point of the rod through a pinhole like this. Question is not easy. Now you see if total height is 3h, so this height is 2h, and this is also 2h, so this is also 2h. So perpendicular and base are same, so this angle is 45, so this angle is also 45. Agree? So we can say this angle is 45 degree. If this angle is 45 degree, this is also 45 degree. Suppose this is angle I, angle of incident is I. Okay, this complete is 2h. So what is this? What is this? This is h. This is h. This is I. Angle of refraction is 45 degree, and this is 2h. This thing is 2h. Now by using value of h and 2h, we can find value of sine I. If this is 2h and this is h, can you find length of this hypotenuse? Under root 5h, right? Length of this hypotenuse will be under root 5h. Agree? So now let's apply Snell's law here. Let's apply Snell's law. By Snell's law, sine I by sine r is equal to 1 by mu. Why 1 by mu? Because light ray is going into rare medium from denser medium. So sine r is 45 degree. R is 45. Sine I upon sine r is 45 degree. So so you'll get 1 by root 2. Root 2 ऊपर आ जाएगा. Sine I root 2 ऐसा आ जाएगा is equal to 1 by mu. So mu is equal to 1 upon root 2 sine I. ऐसे ही होगा ना? हाँ बिल्कुल ऐसे ही होगा. अभी sine, what is sine I? Sine I is perpendicular upon hypotenuse. So 1 by root 2 into sine I is perpendicular upon hypotenuse, means h upon root 5h. So 5 will go upward. Your answer is under root 5 by 2. Understood? Okay, so good diagram, good drawing is important. Okay, you can see this edge directly. Okay, and Suppose this is center. I will explain you question once again. Understand question properly. There is a container whose height is 30 centimeter and diameter is also 30 centimeter, and there is a particle at 5 centimeter at a distance of 5 centimeter from center of container this side. So radius is 15 centimeter. If this is 5, this is 10 centimeter, and I is in such a way that this I can see only edge of the container. Now question is that up to what minimum level we should pour water so that from this position itself this person can see this particle P, right? The question is similar to previous problem. You can try. Okay, time is over. Now we will solve it together. Let's suppose we are pouring water till h height. Okay, let's suppose अगर हम h height तक पानी भर दें तो particle P दिखने लगेगा. Let's suppose तो हम यहां तक. अच्छा, now one thing we missed. This is 30. This is 30. Look at this triangle. This angle is 45 degree already. Okay. Now let us suppose if we fill water till h height, this particle will become visible. Suppose we filled water till h height. Suppose this height is h. This is h. Okay, we poured water till h height. Now this particle will become visible only if ray starting from this particle after reaching surface trace this path. Listen again. I can see this point P only if ray starting from this point P after refraction trace this path. Agree? So let's draw a normal here. Let's draw a normal here, big normal, so that we can achieve a triangle. Okay, this is a normal. Imagine light ray starting from particle P. Imagine light ray starting from particle P. This is angle of incident. Okay, light is going from denser to rare medium, so it will bend away from normal and light will go here. Agree? Agree with this diagram? Lot of calculation is there in this question. If this is 45 degree, this must be 45 degree. So we got angle of refraction already. Okay, let's suppose this distance is x. This is 5. Now there is no use of this 5 anymore. Let's suppose this distance is x and this is h. Already we assumed height of the water h. So unknown is h, but I don't want to bring another unknown, but there is no other option available. We'll have to assume this x because this normal is not coming at the center. In the previous question everything was coming at the center, so question was very easy, but in this we don't know height of the water. That's why I assumed, let's suppose we are putting h height of the water, so this normal is not coming at the center. That's why we cannot put any value here. Let's suppose this is x. Now apply Snell's law here. Let's apply Snell's law here. Sin I by sin R is equal to 1 by mu. Because light is going from denser to rare medium, we don't know sin I, but sin R is 45 degree and refractance is water is 4 by 3, so this will come up and you will get sin I upon 1 by root 2 is equal to 3 by 4. So you got sin I as 3 by 4 root 2. That's good. We got value of sin I. We can use value of this sin I and we can find a relationship between h and x. We can find a relationship between h and x, like tan I is equal to perpendicular upon base. We can write tan I is equal to x by h. And if you know value of sin I, you can find value of tan I. Very easy. Value of sin I is 3 by 4 root 2. Then value of tan I. See, Rohit, yesterday you asked how to find this. Today don't do this. Finding value of tan I by sin I. Sin I is 3 by 4 root 2, means perpendicular is 3 and hypotenuse is 4 root 2. Apply Pythagoras theorem. Apply Pythagoras theorem, you will get this as root 23. So you got 10I as 3 by root 23. Agree? Am I right? See, 16 into 2, 32. 32 minus 9. Yes, it is correct. It is correct. We got value of 10I luckily. 10I is not luckily by solving this. Root 23 is equal to x by h. But the problem is same. We have two unknown. X is also unknown and h is also unknown. Okay. Shall I rub this diagram for further calculation? From b modified, we can write 3 by root 23 is equal to x by h. So we have two unknown. Ankita is saying, look at this big triangle. Ankita is saying you can take another triangle like this. We can take this triangle. Bachcho, look at this triangle. This is 45. What is this complete angle? 45. So x plus 10 by h. See, this complete is x plus 10. So tan 45 is equal to perpendicular by base. Tan 45 is 1. So you can write this. We are not interested in x. We want h. So we can write x is equal to 3 by root 23 h. Substitute here. This is 10, sorry. So at the place of x, you can write 3h by root 23 plus 10. Oh, we solve this. Root 23. Rajul, can you help me solving this by calculator? Okay. What is the question? Object distance is not given. Object distance is not given. Simply they are saying there is a concave mirror in which water is poured till this height, and they are saying take a refractive index of water mu. They want where we should keep an object so that image form on the object itself. Okay. I hope at center of curvature. I hope everyone remember when we put object at center of curvature, image form on C itself. This is P, this is F, this is C. If we put our object at center of curvature, image form on center of curvature itself, right? But the problem is mirror is dipped in a denser medium. So when observer is in denser medium, and it look into any object, suppose this is a point size object and this is me, the height of point size object is x, right? But for me, when I will observe this object, I can see image of this object at height mu x. Hopefully you understood. Agree? So right now mirror is in denser medium, or you imagine yourself at mirror side and mirror is dipped into the water. Okay, so if we suppose object here, let us assume object is at this point. Okay, suppose this is the point size object at a distance, object is at a distance y. Okay, object is at a distance y. Light ray will start from object and light ray will bend towards normal like this, and for mirror, object should look at C. For mirror point of view, this refracted ray, the virtual apparent height of the object must be this much. Okay, so when light ray is going into the mirror, when you retrace these rays must meet at C, then only final image will form at object itself, right? So apparent height of the object must be at center of curvature. Agree? This is real height of the object. Y is real height of the object and apparent height of the object is at C, then final image will form on the object itself. Agree? Let's write if apparent height of the object, if apparent height of object is such a way its image forms at C, then final image will form on object itself. What I mean to say, the actual height of the object is y, but if apparent height is mu y, and apparent height must be equal to this distance. Okay, this must be equal to this distance, and this distance is equal to r minus h. So mu y is equal to r minus h. So Rajul, discharge ho gaya. So r minus h is equal, y is equal to r minus h by mu. So we should keep object at a height y from the water surface. So we should keep object at this distance from water surface. Fan off कर दे. और ये रिकॉर्डिंग हो रही थी तो वो ऑफ होना. From surface of water. Copy. I will explain once again. Solve once again. Because some water poured, the apparent distance will be more than real distance. Suppose this is real distance x, okay, and this is center of curvature. This height is h, this distance is r, so this distance is r minus h. Agree? This is actual height, this is object. Suppose this is actual height, actual distance of object from surface of water, but because of this water level, the apparent distance of this object will be more. So apparent distance will be mu x, and if mu x, this is apparent distance, because light ray will go like this, so when you retrace these rays must meet at center of curvature. So if apparent distance is equal to mu x is equal to r minus h, then image will form on object itself, because everyone knows that when we put object at center of curvature, image also form at center of curvature. So if mu x is equal to r minus h, then image and object will coincide. So object must be kept at distance x from surface of water. Okay, so this is your answer. You should keep object. As you can see, a light ray is right now in glass. It is moving from glass to water and then from water to air. Okay, the value of I, this quotient, the angle I is shown in the diagram of quotient itself. And if ray finally traces the surface of water like this, then they want to know refractive index of glass. Refractive index of glass is unknown. Got B option, right? Okay, let's solve it. Let's apply Snell's law here. First of all, if we apply Snell's law here, we will get sin I into refractive index of glass is equal to sin R into refractive index of water. You can apply this formula also always. Okay, this angle refractive index of this medium mu g, this angle refractive into sine of this angle into refractive index of this medium, like this. You can use this formula. Okay, now refractive index of water is 4/3. Mu g sin I is equal to sin R into 4/3. Suppose this is equation A. Now let's apply Snell's law here. Okay, so when you apply Snell's law here, sin R upon sin 90, because this is the angle of incident here, or you can write it like this: mu water into sin R is equal to sin 90 into mu air. So this is 4/3 sin R is equal to mu air, that is 1. So what is value of sin R? Sin R is 3/4, equation B. Let's substitute value of sin R here. you'll get mu g into sine I is equal to 3 by 4 into 4 by 3. Yes, you all are correct. Mu g is 1 by sine I. Hopefully everyone could solve this question very easily.